Mrs. Robertson, and today we are going to be doing lesson 4, multiple representations of functions. This is in chapter 8, located on page 603. So you should be on page 603, and let's look at our real world link today. Museum. A group of friends are going to the museum. Each friend must pay an admission price of $9. Okay, complete the table and graph the ordered pairs. Number of friends would be X, and total cost is Y. And if you notice, it is labeled that way in the table. All right, so 1 is 9, 2 would be how many, class? 3 would be, and 4 will be, okay. Now, we need to graph that over here. 1 goes up to 9, which is below the 10. 2 is 18, in between 15 and 20. 3 is 27. 4 is 36. And it's a straight line. If you were wanting to look at it, I say it's a straight line there. Describe the graph. The ordered pairs lie on a line. Or you could say it makes a straight line. I don't see everyone's pencils moving. Okay. Number 3, write an equation to find the cost of N tickets. Okay, so Y equals 9 times X. Oh, they want us to use N, excuse me. Since they want N, we should write Y equals 9 times N. Okay, where Y represents the total cost and X represents the number of friends. Okay, I think they should have, I like the idea better here with X as opposed to the N. And number 4, list the ordered pair for the cost when 5 friends go to the museum. Well, if I put a 5 for the input, what will be my output? What's 5 times 9? So the ordered pair would be 545. Put your parentheses around it, and that means 5 units to the right, 45 units up. 5 units right and 45 units up. You all know how to locate your points now, don't you? You're good at that. Great. Let's go on to the next page, 604. Represent functions using words and equations. Okay, in this one it says, a runner's distance in a marathon is equal to 8 miles per hour times the number of hours. So the equation, distance equals 8 times t. T represents hours. So T equals hours and D equals distance. Just write that down in the box there. All right, it says words and equations can be used to describe functions. For example, when a rate is expressed in words, it can be written as an equation with variables. When you write an equation, now remember, equations have equal signs. Determine what variable to use to represent different quantities. We did that on our last test when we were doing equations, where you had to define the variable. You did a pretty good job at that. Let's look at example number 1. The drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to find the total number earned T for selling P pies. Okay, so the total is going to be T. T equals, it's $5 for each pie. How many pies? We don't know. P represents pies. So the equation T equals 5 times P. Any questions on that? All right, now let's look at example number 2. Before we look at example 2, let's read about variables over here. It says under the word variables, you can use any letter as a variable in an equation. If you graph the equation, make sure to label the axis. Okay, like this is the x, this is the y. You would say what that represents with the correct variable. Okay, let's now go on to number 2. In a science report, Mia finds that the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths B a non-active person takes in m minutes. So here, our total is going to be B, all right? So we know it's going to be B equals something. B equals 14 times a minute. Oh, we want to use M for minutes. So it's 14 times each minute. 14M says 14 times for each minute. Okay? Any questions on how they got that equation? All right, let's go down to letter A, and I want you to do these problems. Okay, in letter A mouse can travel 8 miles per hour. Write an equation to find the total distance D a mouse can travel in H hours. Well, D equals, yes. Pardon me? Oh, it's still frozen for you guys? All right. So D is going to equal 8 times H. It goes 8 miles an hour, so how far will it travel in H hours? B, Samantha can make 36 cookies each hour. Write an equation to find the total number of cookies C, so that's your total, she can make in H hours. Well, she can make 36 an hour, so H hours, you just multiply the number of hours times 36. That is your equation. All right, any questions? Great, let's go on to our next page, 605. Now we're going to talk about how to represent functions using tables. So we've already done how to use them in equations. Everyone good with that? Thumbs up. You know how to do those easy equations. They're not going to be hard ones. Now we're going to talk about how to graph them. And I think you all know how to do that too. This is your X, or here it says hours, time hours. This is our X, our input, and this is our Y, our output. Okay? X and Y. 0, 0, over 1 up 8, over 2 up 16, and that is your graph. Any questions on that? Pretty easy, right? So, tables and graphs can also be used to represent functions. Let's look at number 3. The student council is holding a car wash to raise money. They are charging $7 for each car they wash. Write an equation and make a function table to show the relationship between the number of cars washed, C, and the total amount earned, T. Okay? So your equation is T equals 7 times C. All right? Or you could write it as 7 times C equals T. They both say the same thing. Most of you like it this way the best. All right, so if you wash 1 car, you earn $7. 2 cars, 14. 3 cars, 21. 4 cars, 28. Any questions on how they did that? So if they had N car or C cars, it's going to be 7 times C is your rule, and it'll come out as 7C, whatever that is. Any questions on that example? All right, now I want to refresh your memory on independent and dependent. Your input is always your independent variable, and your output is your dependent. Why is it dependent? It depends on what your input is as to what your output is, okay? And remember, input and independent both begin with INs. That's an easier way to remember. Now let's go to number 4 where they've graphed it. Graph the ordered pairs, analyze the graph. Okay, 1 car 7, 2 cars 14, 3 cars 21, 4 cars 28. And if you had to describe it, they make a straight line, right? That's all you have to do. If they say describe the graph, the points are in a straight line, all right? Or it's a linear equation, something like that. If they don't make a straight line, you say it's a crooked line, something like that. Any questions on how to describe a graph? Very simple. Let's go on to page 606. I want you to do this example. It says, while in normal flight, a bald eagle flies at an average speed of 30 miles per hour. Write an equation and make a function table to show the relationship between the total distance d, so here they want you to use the total distance d that a bald eagle can travel in h hours. So it's going to be d equals something, okay, because they gave you the variable to use. And then in part d, you're to describe it. Like, is it a crooked line? Is it a straight line? Something like that. So do that right now. All right, so the equation for letter C, distance equals 30 times h. And 1 hour, 30 miles, 2 hours, 60, 3 hours, 90, right? So then we graph it. 1 is 30. 2 is 60, 3 is 90. And how would you describe that? It makes a line. It's linear. Okay, it makes a line, or if you write the word linear, the answer the book has, it says the graph is linear because each hour of flight, the distance increases by 30 miles. And if you wanted to go into more detail, you could do that. Okay. All right, make mine a little. Any questions? All right, let's go on to the guided practice. In number 1, the school cafeteria sells lunch passes that allow a student to purchase any number of lunches in advance for $3 per lunch. Write an equation to find T, the total cost. So T is the total cost in dollars for a lunch pass with n lunches. Okay, so it's $3 a lunch. So the total will be 3 times however many lunches you buy. Okay, does everyone see how I got that equation? Good. Make a function table to show the relationships. Okay, I'm going to just put in an extra box. I'm going to go 0, 1, 2, 3. All right. If you buy 0 lunches, how much is it going to cost you? $0. If you buy 1 lunch, 1 times 3 is 3. If you buy 2 lunches, 2 times 3 is 6. 3 lunches is going to cost you 9. Any questions? Now let's graph it. 0, 0. Number of lunches, 1. Total cost, 3. So make sure you go number of lunches this way, total cost that way. 2, 6, 3, 9. And graph the ordered pair. Analyze the graph. It is linear. It makes a straight line, okay? Any questions on this? That's what we're doing today. This is really very friendly. I think you're doing, you can, if you understand it, you can circle the clear, somewhat clear, not so clear. I think most of you are going to be clear. There could be a little bit of cloudiness in how you're understanding it. Once again, if you have problems, go to your online book, and there's a personal tutor that could help you if you don't understand this. Do you see that symbol? That's what you would use. Now, what are we going to do for homework tonight? Or classwork? We have, 25 minutes, 20 to 25 minutes. We're going to do page 607 all. On page 609, you're going to do number 3, all of the parts. All right, it has 5 parts. Then we are going to go to page 609, or excuse me, that was 608. 608, do number 3. On page 609, do 8, 9, and 10. It's not going to take you long to do those. Page 609, 8, 9, and 10. And that'll be it. You should be able to get that done in class. I will walk around the room and help you if you have any questions. All right.